Functions f and g have domains here and here, respectively, and are defined by these f of x is x squared minus 25, g of x is 2x minus 3. Write down the domain of f of g. Write down the range of f of g. Write down an expression for f of g of x. Solve the equation f of g of x equals 0. The function h is defined by this. Show that h of x is equal to x. Hence, write down an expression for h minus 1 of x, the inverse of h. So here we go. Here's the question in summary form then. The domain of f of g. So part 1. So domain of f of g then is equal to the domain of g, isn't it? Because that's f of g of x. And the domain of g is 0 to infinity. Part 1. Part 2. So we've written that down. The range of f of g. Okay, so the range of f of g. X squared minus 25 f of g. This goes from 0 to infinity. Okay, so the range of f of g. Well, we need to work out f of g really, as far as I can see. Although this is x squared minus 25, if g varies from 0 to infinity, as g, so if we look at this 0 to infinity, the 2 times 0 is minus 3 to infinity, isn't it? And from minus 3 to infinity, if we look here, minus 3 would be, it will go through 0. Minus 3 would, so minus 3 to infinity would cover, encompasses 0 to infinity, and 0 to infinity is half of this quadratic curve. So as x varies from 0 to infinity, this will vary from minus 25 to infinity. So I reckon the range of f of g, just by looking at it here, f of g will actually be from minus 25 to infinity, because 0 is included in this value. The g, if you put in x is 3 over 2, you get a 0, and x is 3 over 2 is in here, and the f of 0 will be minus 25, and anything after that is also in the specified conditions, and so you can take x as large as you want. So you end up with this. So that's that. But really, the helpful thing is to get f of g of x, isn't it? Let's have a look at that function. F of g of x is equal to f of g of x, which is equal to f of 2x minus 3. So that was g, and x squared minus 25. So that's equal to something squared minus 25, which is 4x squared minus 6 is minus 12x, plus 9 minus 25 is minus 16, which is equal to 4x squared minus 3x minus 4, and that's equal to 4 lots of x and x, 4 ones, 4 and 1, minus and a plus. Yeah, x squared minus 4 plus 1 is minus 3, and plus times minus is minus, 4 ones are 4. So there's f of g of x then. Okay, so solve that equals 0 then. So here 4, here f of g of x equals 0 when x equals minus 1, or when x is equal to 4. Just by letting this equal to 0, you can see x is minus 1, or x is 4. Part B. Okay, h is 2x plus 7 over 5x minus 2. h of x then? is h of 2x plus 7 over the 5x minus 2. Yeah? And that would be, so this is our h now, and it's 2 times something plus 7 over 5 times something minus 2. There's the function h. The something on which it acts is this thing here, 2x plus 7 over 5x minus 2, and 2x plus 7 over 5x minus 2. Okay, so I'm going to put little brackets around here because we're going to move things around. Multiply top and bottom by 5x minus 2. We'll remove it from underneath here, but it will pop it up here on the top. And underneath, we'll have 5, 2x plus 7 again. And that will disappear, but minus 2 lots of the 5x minus 2. So let's see what we get then. So that equals 4x plus 14 plus 35 x's minus 14. And then we've got 10x plus 35 minus 10x, which looks good, plus 4. So the 14's cancel on the top. We've got 39x over. The 10x is cancelled underneath, and we've got 39 underneath. So that is equal to x, which is what we wanted to show. So we've done that. Part 2, what's the inverse of h minus 1x? So that was part 1. Now part 2. So y is equal to 2x plus 7 over 5x minus 2. So let's move things around. Let's move this up there. 5x minus 2 times y is equal to 2x plus 7. So let's bring the x's over together. So we've got 5xy minus 2x on the top, here and here, and then move the 2y over to be plus 2y from minus 2y, plus the 7 that's already there. So we can take an x outside now. We've got 5y minus 2 is equal to 2y plus 7. And that tells us that x is equal to 2y plus 7 over 5y minus 2. But we really didn't need to do all that, did we? Because we know the inverse, this times its inverse, is the identity function. So we already know what h minus 1 is because it's equal to h, which is what is illustrated here. So h minus 1 of x, and just writing it down, will be 2x plus 7 over 5x minus 2. And that equals h of x. So this work was really unnecessary, because we could have just got it from before.